All right, good afternoon again, everyone.
Good
So,
afternoon.
hi, Rachel. So, for this afternoon, my regular device once again is not working. So, I am on my phone, and for that reason, you're not able to see the background as well as the PowerPoint. I'm trying to see if I can send the PowerPoint to my emails as I can access it from my phone. If that does not work, I will just have to perhaps switch around my camera and show the PowerPoint from my laptop. QA, is this your first time with us?
Yes, miss.
All right, welcome. Thank you for joining us. In the first 2 weeks of classes, can you believe it? Is it already two? Is it already 2 weeks? This is the second week. Yeah. In our first 2 weeks of classes, we have looked at directed numbers, so positive and negative numbers. And this week, we should be starting our look on the basics of algebra. And to start us off, when we do any of our exercises, we usually do a math riddle or any riddle that can, get us thinking critically about whatever the riddle is asking us to do. Porter, can you pronounce your first name for me, please?
Caradine, miss.
Caradine, and you are in
Yes,
grade 7?
yes, miss.
All right. All right, great. Thank you for joining us today. Today is also your first time?
Yes, miss.
All right, great. Welcome.
Thank you.
Okay, so let me see if I can share. Let me see if I do have the riddle up. All right, so I'm not seeing Jaden. Jaden is one who should be sharing a riddle with us today, but I'm not seeing him. Rachel, do you happen to have any riddle for us today?
Uh, hold on. Miss, can I? Oh, yes, Miss, I have one.
All right, so I'll give you a minute. Do you have it nearby where you can share it now or give you a
Yes,
minute?
Miss. I have it now.
All right, so Kiwane, Harmony, and Kerdine, please listen as Rachel will give us our riddle or puzzle for today's session. Go ahead, Rachel. Remember to give them some time and you know the protocols, have them raise their hand and so on, okay?
Okay, Miss. So my riddle is what has teeth but cannot be eaten?
Rachel, that's a tough one.
Uh, does anyone have
But
any
it's fine though.
answer?
It's fine. You can continue.
Miss, you want me to give another one?
No, this one is fine. You have to ask your classmates and see what they say.
Okay. Does anyone have any answers?
Can you repeat it?
It says what has teeth but cannot eat? Okay, Harmony, you can go.
A comb?
Yes, she got it right. Oh, Queuing, you can go as a
Fork.
no. The correct answer was a comb. But good try.
Rachel, can you share with us why it couldn't be a fork?
Miss, because sometimes, I mean, it can be a fork as well, but that's what I was saying. It could be a fork, but I looked on Google and it said a comb. But it can also be a fork as well.
Well, I am thinking that it couldn't be a fork because the fork actually, if you put it in quotations, when the fork goes into food, I mean, it is technically kind of ish eating, if you get what I'm saying.
Yes.
Yeah, but I mean, yeah, comb is okay because the teeth of the comb doesn't go into any food at all. It goes into here.
Yes.
So I guess, so I guess you can work with that one. I see someone just QA rejoining. All right. Um. So let me see now for our. I may just have to. I'm just gonna switch around my camera to make it easier. All right, is that okay, everyone? I'll just switch it around and then that will allow us to go through. So I will skip over the brain teaser because we have just done that with the help of Rachel. Thank you very much once again.
You're welcome.
All right. So are you all able to see my screen, my
Yes.
laptop screen with just, so what you can do is just pin my, well, I think you should be able to like pin my view or something of the sort. Right. So we're not going to do this brain teaser. Let me see. All right. So we're going to watch this video.
Did you download Grammarly? Come on, man.
Are you hearing it?
Hi, this is Rob. Welcome to Math Antics.
Yes, miss.
Yes, miss.
All right, great. Let me take off the closed caption and let me full screen it. So in case you would have missed the introduction for this session, we are starting our look on algebra or the basics. Hi, Tiana. We're looking at the basics of algebra and we're looking at starting off with the fundamentals. And hence we're looking at this video by the group Math Antics, and it is entitled, What is Algebra? Some of you, depending on if you like to explore, you may have seen this video before. If you have, I'm going to ask that you still feel free to watch and to refresh your memories on what algebra is. And let me just once again apologize for how this session is being presented because my laptop is not allowing me to launch Zoom anymore. I'm not sure why. So I have to be using my phone to continue with the sessions. So please continue to bear with me. And we won't be watching all 12 minutes of the video.
This lesson, we're going to learn some really important things about a whole branch of math called algebra. The first thing you need to know is that algebra is a lot like arithmetic. It follows all the rules of arithmetic, and it uses the same four main operations that arithmetic is built on: addition, subtraction, multiplication, and division. But algebra introduces a new element, the element of the unknown. When you were learning arithmetic, the only thing that was ever unknown was the answer to the problem. For example, you might have the problem 1 plus 2 equals what? The answer isn't known until you go ahead and do the arithmetic. Now, the important thing about algebra is that when we don't know what a number is yet, we use a symbol in its place. That symbol is usually just any letter of the alphabet. A really popular letter to choose is the letter X. So in arithmetic, we would just leave the problem like this. 1 plus 2 equals blank. And we'd write in the answer when we did the addition. But in algebra, we'd write it like this. 1 plus 2 equals X. The X is a placeholder that stands for the number that we don't know yet. What we have here is a very basic algebraic equation. An equation is just a mathematical statement that two things are equal. An equation says the things on this side of the equal sign have the same value as the things on the other side of the equal sign. In this case, our equation is telling us that the known values on this side, 1 plus 2, are equal to what's on the other side, which happens to be the unknown value that we're calling X. One of the main goals of algebra is to figure out what the unknown values in equations are. And when you do that, it's called solving the equations. In this equation, it's pretty easy to see that the unknown value is just 3. All you have to do is actually add the 1 and 2 together on this side of the equation, and it turns into 3 equals X, which is the same as X equals 3. So now we know what X is. It's just 3. That almost seems too easy, doesn't it? And that's why in algebra, you're usually given an equation in a more complicated form, like this. X minus 2 equals 1. This is exactly the same equation as 1 plus 2 equals X, but it's been rearranged so that it's not quite as easy to tell what X is. So in algebra, solving equations is a lot like a game where you're given mixed up, complicated equations, and it's your job to simplify them, rearrange them until they're nice simple equations, like X equals 3, where it's easy to tell what the unknown values are. We're going to learn a lot more about how to actually do that, how to solve equations, in the next several videos. But for now, let's learn some important rules about how symbols can and can't be used in algebraic equations. The first rule you need to know is that the same symbol or letter.
Is everyone still able to follow so far?
Yes, miss.
Yes, ma'am.
Yes, miss.
All right. I will try at the end of the session or close to the end of the session to see if I can send a link for this video from my phone, okay? Because I'm sharing it from my laptop, I'm not able to copy and paste it in the chat. So I will just see if I can quickly find it, close to the end of the session, find it and post it in the chat so you can go back and watch it, okay?
Okay, miss.
All right, thank you very much again for understanding.
Letter can be used in different algebra problems to stand for different unknown values. For example, in the problem we just solved, letter X was used to stand for the number 3, right? But X could stand for a different number in a different problem. Like if someone asked us to solve the equation 5 plus X equals 10. In order for the two sides of this equation to be equal, X must have the value 5 in this problem, because 5 plus 5 equals 10. So X, or any other symbol, can stand for different values in different problems. That's okay. But what's not okay is for a symbol to stand for different values in the same problem at the same time. For example, what if you had the equation X plus X equals 10? This
Yes, go ahead. Yes. Amanda? Amanda? Like someone was just saying something?
No, miss.
No, I thought I heard someone saying something when they joined, because I'm seeing Amanda and I'm not. Oh, Amanda just got dropped from the floor. Okay, so I'll continue then. So far, what we've been looking at is just breaking up our expressions into some key terms.
Equation says that if we add x to x, we'll get 10. And there's a lot of different numbers that we can add together to get 10, like 6 and 4. But if we had the first x stand for 6 and the second x stand for 4, then x would stand for two different values at the same time, and things could get really confusing. If you wanted symbols to stand for two different numbers at the same time, you need to use two different symbols, like x and y. So in algebra, whenever you see the same symbol repeated more than once in an equation, it's representing the same unknown value. Like if you see a really complicated algebraic equation like this, where x is repeated a lot of different times, all those x's stand for the same value. And it'll be your job to figure out what that value is. Okay, so for any particular equation, we can't use the same letter to represent two different numbers at the same time. But what about the other way around? Could we use two different letters to represent the same number? Yes, and here's an example of that. Let's say you have the equation a.
All right, so right now what is being demonstrated is how we can have like terms and unlike terms. And he will continue to give some examples of identifying and using variables. Now, if we skip a little bit further,
In a lot of algebra problems, and it has to do with multiplication. Here are the four basic arithmetic operations: addition, subtraction, multiplication, and division. Although in algebra, you'll usually see division written in fraction form, like this. In arithmetic, all four operations have the same status, but in algebra, multiplication gets some special treatment. In algebra, multiplication is the default operation. That means if no other arithmetic operation is shown between two symbols, then you can just assume that they're being multiplied. Multiplication is implied. For example, instead of writing a times b, you can leave out the times symbol and just write ab. Since no operation is shown between these two symbols, you know that you're supposed to multiply a and b. Of course, you can't actually multiply a and b until you figure out what numbers they stand for. The advantage of this rule about multiplication is that it makes many algebraic equations less cluttered and easier to write down. For example, instead of this, a times b plus c times d equals 10, you could just write ab plus cd equals 10. You can also use this shorthand when you're multiplying a variable and a known number, like 2x, which means the same thing as 2 times x, or 3y, which means the same thing as 3 times y. Since the symbol and the number are right next to each other, the multiplication is implied. You don't have to write it down. Finally, some good news. Now I never have to write down that pesky multiplication symbol again. Oh yeah. Not so fast. There are some cases in algebra where you still need to use a multiplication symbol. For example, what if you want to show 2 times 5? If you just get rid of the times symbol and put the 2 right next to the 5, it's going to look like the 2-digit number 25, which is not the same as 2 times 5. So, whenever you need to show multiplication between two known numbers, you still have to use the times symbol, unless you use parentheses instead. But aren't parentheses used to show grouping in math? How can you use that to show multiplication? That's a good question. Parentheses are used to group things, but whenever you put two groups right next to each other with no operation between them, guess what operations apply? Yep, multiplication. For example, if you see this, it means that the group a plus b is being multiplied by the group x plus y. We could put a time symbol between the groups, but we don't have to because it's the default operation in algebra. The multiplication is just implied. So, going back to our problem, 2 times 5. If you wanted to, you could just put each of the numbers inside parentheses like this, and then you could get rid of the multiplication sign. Now, this can't be confused with the number 25, and since the groups are right next to them.
All right, so as you can see, that was demonstrated our, excuse me, Algebra pretty much looks at your unknown, and the letters of the alphabet are used as symbols to represent your variables. And with these, and when you're selecting your variable, you can use different variables to represent the same number. However, you do not use the same variable to represent different values, because that will cause confusion. Some key terms when working with, so you'd have seen some of these demonstrations in the video where we're just looking at regular arithmetic expressions. Now these we can go ahead and work out. And we would have looked at some items similar to this when we did our directed numbers. So since we're here, I'm gonna let me see how many of you are online now. We have Kirin, we have Tiana, we have Amanda, Saverna. I'm not sure if you're the one using the device or someone else. I'm seeing Saverna Braham Smith.
Miss,
Are you the one using?
person, miss, using it, miss.
Okay, give me your name, my dear, so I can rename your device.
Wayland Smith, I'm joining it with another device, miss.
Oh, you're gonna join? Okay, no problem. I can wait on you.
1 minute.
Okay, wait. Yes, Wayland, I see you. So you can exit. You can exit with this one. All right. So we have Wayland, we have Tiana, Amanda, Huane, Cardine, Harmony, and Rachel. So I'm gonna ask each of you to share your answers. You can just type it in the chat and I'll look. Just share your responses. So if I have 12 plus 6, what would I get? Okay, I see the responses coming in. All right. So let me go ahead and type that. Sorry. And then what about, thank you. And then the next one. The next one. Rachel, I think you actually typed the incorrect number for the one that you have. You said 3 times 13. Yeah, I think you should have, well, not think, you should have had 12 and not 36. I mean 12 and not 13. All right, I think now, yeah, I realized it was a mistake. So for this one right here, we could do this one 2 ways. Can anyone share with me the 2 ways we can do
camera's
this?
off.
Is it still off?
It's on now.
You're still not seeing my camera?
Miss, you can see it now.
Oh, I think I know what happened. When my phone screen closes automatically, like it locks, I think everything just basically closes. Yeah, I'm really working on sorting out my device because this cannot continue at all. Hopefully by next week, all will be sorted out. All right, so yes, Harmony, go ahead.
Miss, for one of the ways you can work out this question is that you would have 6 multiplied by 3, which is 18, plus 2, which gives you 20, which I learned today because you'd have to do the equation from left to right.
All right, question. Are you sure it's just 18 plus 2 and not distributing the 6 times the 3 and the 6 times 2?
Miss, I don't think it would be like that because then it would have been 3 plus 2, which is 5, times 6, which would have been 30.
Yeah. So if you do 18 plus 2, 18 plus 2 does not give you 30. Are you seeing what I'm getting at?
Yes, miss.
Okay. So the point I want to emphasize, so thank you, so Harmony, your method that you pointed at is correct. Just one of the steps need a little bit of fixing. The method that she's talking about, classmates, is that what we call the distributive property, where you're distributing the term that's on the outside of the bracket to each term that's within the bracket by a process of multiplication. So it's going to be 6 times 3, which is 18, plus 6 times 2, and that's 12. And when you add that up, you will get 30.
Miss, I have a question.
Go ahead, my dear.
So 6 times 3 is 18. Why wouldn't you just, since you already did part of the equation, why wouldn't you just add the 2?
Okay, so thank you very much for asking that question. That is important. And it is similar to what Harmony started earlier. When you look at this expression, right, it is saying that we have 6 groups of 3 plus 2, right?
Yes, miss.
So if I were to write it out, I would have 3 plus 2, that's one group, plus another group, 3 plus 2, and then I'll write that again until I have 6 of them, meaning I'll have 6 3s and I'll have 6 2s, because that's what this means. This means 6 groups or 6 times the number of 3 plus 2. And if we're using the distributive property, it simply means that, sorry about that. If we're using the distributive property, it simply means that each term in your bracket is distributed to whatever is immediately on the outside. So that is why we cannot just say it is 80 just multiply the first term alone, because the second term is also within the bracket, which is going to be affected by the 6 that is outside of your bracket. Is that clear, Rachel?
Yes, miss.
All right. Oh, by the way, this I didn't get to complete this because I'm using my my touchpad, so it's difficult to write it out.
Okay.
So the next, yes, and then the next method would be to work out what's in your brackets first. If we follow order of operation, so if we work out what's in our bracket first, we would get what? 5, because 3 plus 2 is equal to 5. So the next method, let me write it here, would be 3 plus 2 is equal to 5. And then this 5 is being multiplied by 6. And then 6 times 5, that's 30. So, and that we can even use this method, the second method, to help to double check if our distributive method was correct. Any questions so far?
No, miss.
All right. Now, what about the final item? What about the final item? I'm seeing some answers. I'm not sure if I quite agree with some of the answers I am seeing for the last one, where it says 15 take away 4 bracket 6. Do you know what this part means? Do you know what that part means?
Miss, for me, your camera is glitchy.
Are you seeing it now?
Yes, Miss, I'm seeing it.
Okay, I'm really sorry about the technical issues today, ladies and gentlemen. I really am. I thought the matter would have been fixed because I have minimized some of my operations, and I've even taken off some files off my device, off my laptop, but it's still not allowing Zoom to load. I only have one other thing open, and that's the Zoom login and the PowerPoint. So I'm still not sure what's going on. So it may definitely be a device issue and not necessarily internet. All
Okay.
right.
Yes.
Yes. So I'm really sorry about that. So, but I do hope by next week or so, all will be rectified. All right, so let's get back to the final item here. I know this is not our primary focus, but this can serve also as another type of revision for working with directed numbers. So the 4 and the 6 here, this actually means, and it was mentioned in the video by Math Nov. So this actually means a multiplication. And order of operation will tell you that you are to do your multiplication first. So I noticed based on the response in the chat that the subtraction was done first and then the multiplication. You have to remember your order of operation that talks about your brackets, your exponents, then you multiply or divide, then you add or subtract. Some of you may call it BODMAS, BOMDAS, PEDMAS, whatever name you have for it, it is still referred to as order of operation. So we're actually doing this multiplication part first. So 4 times 6 gives us what?
24.
Come on.
24.
24, excellent. And then can I take all of 24 from 15?
No, Miss.
So 15 take, all right, but what can I take away? What would be left?
Negative
If I take away 20, negative how
9.
much? Sure.
Yes. Miss.
All right. Okay. Yes, that's correct. Continuing with our slide. So as we mentioned before, a variable, that's your letter or the symbol that we use to represent any value. And it is not, so when you have your variable, it is only assigned a value based on what you're working it out to be. But the variable overall can take on any value. But when it gets a value, it only gets one value at a time. Hold on. Why is that not showing? Give me a second, please. Let me, I think I know what the matter is. Your microphone is open. I go, mhm. Your microphone is open. Thank you. Yeah, that means it didn't change. Give me a second. I thought I had changed out all of them. There we go. So our algebraic expression, let me quickly go back to slide share mode. So your algebraic expression is pretty much once you have a variable term in it, that's an algebraic expression. So whether there's a letter and there's some other terms, whether it be other letters undergoing addition, subtraction, multiplication, or division, those are your expressions. And remember, as was mentioned in the previous video, you don't have to write your multiplication sign. Once you see a coefficient or a number beside a letter, or even letters beside letters, the default operation is going to be multiplication. Any questions so far? Any questions so far?
No, miss.
All right. And some of these you perhaps will remember from primary school. Now, coefficients are your terms or your most times or sometimes your numbers that are directly attached to your variable. And the attachment here is usually by an operation of multiplication. So from the examples or from the expressions here, we have 6m plus 5. The 6 is multiplying the m. 6 is directly attached or closely aligned with your variable m. So we can say that 6 is the coefficient of m. We have two variables in our second expression. We have variable r and variable m. And to these variables, we have 8 as a coefficient of r, and we have 7 as a coefficient of m. 4 doesn't have a variable or a letter assigned to it. And we'll be looking at this later down. 4 and 5 from these two expressions will be called a constant, meaning their values are fixed. And then the final example here, 14b take away 8. 14 is our coefficient. And just a side note, our constant here would be negative 8. And I say negative 8 because in this instance, whenever we are looking at our terms individually, we will usually assign them the sign that is to the left of them.
Miss, I think something's wrong with Mike.
Say again. I'm not hearing. Can you please say again?
Miss, there's something wrong with your mic. Whenever you try talking, there's a feedback or something.
Is this the same for everyone? Please let me know.
Yes, miss.
Yes, miss.
Yes, miss.
Wow. Like how loud is it? Can you give me an example? Like what does it sound like?
Miss, it sounded like maybe a fan.
Oh, I get you. Are you still hearing it now?
No, miss.
No, miss.
Because what I was using my headphone a while ago because as I said I'm on my phone, but I just took it out to see if the you would still have difficulties, but you say you're not hearing the feedback in here at all.
No, Miss.
Okay, I guess I'll just keep the headphone out then. Let me see the time frame that we have. Okay, we have a few more minutes, so we should be able to go with the just without the headset, right, everyone? Is that okay?
Okay, Miss.
Yes, miss.
All right, thank you very much. Thank you. All right, so let me see if so the next two items that we're to look at are our terms and constants. And I'm going to bring back up the camera in let me see, because I'm trying to make sure. Okay. And we are good to go. So let us look at what we call a term. Are you seeing my screen?
Yes.
Okay. So once we have a term, it is the name that's given to any number or any variable that we have. So sometimes we can have a combination. And you can assess the examples that are here. We have A and we have 2. So our terms in this case would be A and 2. And then in the second example, we have 1, 2, 3 terms. And notice that we have written -6 and not just 6. Okay? Because we're looking at them now as individual. And also remember that we don't usually like write the positive signs. But we do know that once we do not see a sign, we take it that it's in the positive name, it's in the positive. So we have positive 3m, and this would be a positive 6m. Right? So this is what happens when we break it up into the individual components. Now, next, any questions, by the way, my apologies, any questions?
No, miss.
All right, everyone able to follow so far?
Yes, Miss.
Yes, Miss.
All right. Okay, Tiana, are you okay? I don't think I've heard you since you joined.
Yes, Miss.
Amanda, what about you? Wait, what about you? Are you okay?
Yes, Miss.
Yes,
All
miss.
right, great. All right, great. Thank you very much. So let us look at then now the final thing that we're looking at is what we call our constants. So as we mentioned before, constants, these values are always fixed. So once you see a number and there's no letter attached to it, that's your constant. And your constant, remember, we'll take the sign, or any term for that matter, we'll take the sign that is to the left. And if you do not see a sign to the left, you will assume that the sign is positive. So we have a plus 5x, we have a positive 7y, and we have a negative 2. So our constant in this case, the only fixed value that we have here is the negative 2. Can you tell me why 5x and 7y are not fixed? You can raise your hand. Yes, Harmony, go ahead.
Miss, it's because it has a variable next to it. So it wouldn't be a constant, it would be a coefficient.
Thank you very much. Anyone else would like to share?
Um.
Yes,
Oh,
go ahead.
never mind, Miss.
Why you change your mind, Rachel? Why you change your mind?
Miss, I don't know. Never mind.
Yes. All right, then no problem, my dear. And then this should not be blank. This, oh, okay. So let us quickly look at this video as it will give you an idea if it would only allow me to point at it. Give me a second. Let me see if I can just get this. I'm trying to have the video play, but it's not. It should be playing directly. Okay. All right, so this video, let me just quickly give you a summary. What it does is it gives you an example of identifying your terms in an expression, then it breaks down each of your terms. So as you can see from the photograph assigned to the video, you will see the terms being identified, and then it will go further to identify which of the terms are constants, which of the terms are coefficients, and which terms are alike. And like terms simply meaning grouping letters or even just constant terms together. Okay, so let me see if I
So,
can go
Miss,
ahead. Yes, Harmony, go ahead.
Miss, I'm asking for the like terms. Would it have to be something like 7x and 2x would necessarily be the same thing?
Yes, you are correct. So from the picture, those would be like terms from the expression here. All right, so let us just go ahead and try. I may not have time today to, I will try to do so. Let me check the time, by the way. It is now 6:24. I'm gonna allow us to try this item. And while you're trying this, I'm going to see if I can, oh no, but I won't be able to try it because I'm using my phone as the screen thing. Okay. So I'm going to ask you to go ahead and identify the terms, the coefficients, and the constants. You're not identifying any like term, just follow what the instruction says. After you have done this, and once you're finished, just please raise your hand. After you have done this, I'm going to ask if you're able to stay like about 2 minutes while I go ahead and see if I can find the videos on my phone and then just post the links in the chat. All right, so please go ahead and do this item or do these items. Anyone finished as yet? Anyone finished? All right, let's see if we can talk as we go through. So what are the terms in expression number 1?
Miss, like, read the equation.
Say again.
Miss, should I read the equation?
Yes, tell me.
Okay, Miss. It says 12a minus 6b plus 4.
Thank you very much. And what are the terms? How many terms do we have in this expression? How many do we have? You can count them. How many? How many terms? We have 3 terms. We have 12a, and we have negative 6b, and we have 4. Now, which of these 3 terms is the constant? Someone's microphone is open. Thank you. Now, which of these 3 terms would be called a constant? You can type or raise your hand and I'll identify you. Waylon, do you have a response? Amanda, which of these terms would be the constant? 12a, negative 6b, or 4? Which would be the constant?
The constant would be the negative 6b.
Close, but remember your letters are variables, meaning that they're not fixed. Which value here would not change no matter what you do with it, no matter where you move it? Think about it, Amanda.
The positive.
I see your hand, Harmony. I'm giving Amanda. Thank you very much. I was giving Amanda another chance. You're correct. And then what are our coefficients? Okay, go ahead. I see 2 hands. Harmony and Rachel, go ahead.
Wait, Miss, what was the question?
Coefficient. Give me one of the coefficients.
12a.
All right, so 12a is the term, but what is the coefficient of the term 12a?
Minus.
No, what's the coefficient meaning? All right, so your coefficient is usually attached to your letter. What is attached to our letter A?
A.
Yes, but what is attached to the A? What is multiplying the A? What value do we have multiplying the A? What number do we have beside the A, Rachel?
12.
So 12 is considered to be the coefficient of A. Okay?
Okay, Miss.
All right, Harmony, your hand is still up. So go ahead.
Miss, I'm saying that the coefficient of the second term would have been 6.
Just 6. What about the negative part of it? Wouldn't we consider that?
Okay, Miss, it's negative 6.
You just agreed with me without even saying, yeah, Miss, I forgot. Yes, you have to consider the negative side, okay? Tiana, would you like to do the second one? And then Kiwane. Kiwane.
Yes, Miss.
Yes, would you like to identify the coefficient in number 2? What would be the coefficient?
4x
Okay, so 4x would be a term, but what is the coefficient in 4x? What is multiplying the x?
4.
4. So 4 is considered to be a coefficient of x. And it's also a positive 4, okay?
Yes, miss.
All right. Okay. I'm going to let us stop right here and so as I can share with you the 2 video links, okay?
Miss.
All right, so if you're able to stay a few minutes to wait for me to share the 2 video links, please just remain. And let me just say once again, thank you very much for joining us in the session. Whether it's your first time, your second, or your third time joining us, please continue to join us. We will be doing this every Monday and Tuesday until the 14th or 15th of December, somewhere in that time frame. And I do, as we progress, looking at some of the topics that you will be doing throughout this term, you will be able to understand and learn more math as we go along. Okay, so I am going to